There are some parallels between graphing in 3D and graphing in 2 dimensions that we should explore. So the idea here is that the big idea is if we're in 2 dimensions, I'm going to do a little 2-dimensional graph over here. Our horizontal axis is our x-axis and our vertical axis is our y-axis, and we can think of a graph as a number of x's or the set of x's and y's that satisfy some condition. So if I said I want to graph the points where y is equal to, let's say, x plus 2, well, you would just say, hey, Mr. Steiner, that's a y-intercept of 2 and a slope of 1. So I have my line like this. Boom, I'm done. Right? This line represents, especially with these pointed tails, represents all of the x's and y's that satisfy this condition. And we could also look at this in standard form, right? This equation is no different from x minus y is equal to -2. These are exactly the same statement, only the terms are rearranged. And again, this line represents all of the x's and y's that satisfy this condition. Okay. Well, graphing in 3D is going to be very similar to that. We want to, so let's suppose I said all the z's that are equal to, oh well, let's step back for a second. What if I asked for the line? I'm going to do this in red. I want to know, or not the line. I want to know I want to graph all the points where y is equal to 2. You would say, hey, Mr. Steiner, that's just a horizontal line going through y is equal to 2. Just like that. But I would say, absolutely right. That's just a horizontal line. Does x really matter? And you would say, well, x kind of matters. I mean, x can be anything as long as y is equal to 2. We're on this line. What about the line x? I'll do this in blue. What about the line x is equal to 4? Well, I just go right here, and this is not a function, but it still is a line. It looks just like something like this. I do something here. I think nope. So you would just draw a straight line like this. Okay, so what about 3D? Let's suppose I said I want to know all the values where z is equal to 7. Well, here we're graphing over this xy plane. You have to think of like we're graphing in this box here. And what about where z is equal to 7? Well, z is equal to 7 all along this line right here. Right? So this is, I think of this as a height. Where are all the points that we are exactly 7 higher than the xy plane? And you can kind of see this you can see this plane filling up here. Maybe I can color it in. Let's color it in red. This plane right here is equal to z is equal to 7, and it would go on forever, just like these lines go on forever. And this is a constant; it just stays. X and y does matter, but as long as z is equal to 7, this is perfectly legitimate plane. And then if I said, what about all the z's? Let's say z is equal to x plus y. Well, in that case, you would, so this would be a different thing here altogether, and we would take each x plus y, and I might want to get rid of this, Mr. Steiner, because What if we looked at this one right here? We said z is equal to x plus y. Each, just like here, we would look for all the things that satisfy this. Well, x plus y, so we'll look at this point right here, 1, 1, z is equal to 2, which would be kind of hanging up here. At x equals x and y both equal to 0, we'd be here. This point is where y is equal to 1, x equals 0, and it would be here. And you can kind of see the as we get farther and farther this way on the xy plane, the x's and y's that go into this function are going to get larger and larger. And you can kind of, hopefully you can kind of see, let me get rid of this one here, rid of this line. You can kind of see wherever you're standing looking at this computer screen, this plane is going to come out at you. And if you don't see it right away, don't worry, we're going to do lots of examples. Should color it in. This is kind of going back down. It gets darker as we get farther away. Okay. Oh, and these two planes intersect, right? Because this one's coming out at you, and it intersects right along some kind of line like that. Where is this line? This line is on both planes. It's on z equals 7 and z equals x plus y. Okay, I hope that wasn't. Hope you're cool with that.